Hello everyone, this is Mr. Appel, and today we're going to do a little review of imaginary and complex numbers. You should remember this, hopefully not all of this from Algebra 2, but you may need a refresher or may not have totally understood it at the time, and so I want to address that right here, so let's get started. Whoops, give away the punchline there. So to start, you probably know the answer to this question, but how do you take the square root of a negative number? Well, in real numbers, the answer is you don't. You can't take the square root of a negative number. It's not real. So how do we deal with it? We actually make up a whole new set of numbers, and since they're not real numbers, since it's not real, it's fake. It's actually called imaginary numbers. They're fake numbers. They're not real. That's not even like made up. It is made up. That's what mathematicians did. They made it up. Okay? So they made up this new set of numbers, and it all stems from this. They define the square root of a negative, the simplest one there is, square root of negative 1, to be this constant I. And I usually write I as a script I, just because when you write it this way, if you write it messy, it can end up looking like something else. So I like to write it as a script. And I represents the square root of negative 1. And once we've defined that, it allows us to simplify expressions that have negatives in them and work with them. Again, these are not real numbers. We're introducing a new set of numbers, so they're not real. So if I had something like square root of negative 36, I could rewrite that as the square root of negative 1 times the square root of 36. And now I've got part of this I can do something with. I know how to simplify that. So we have the square root of negative 1 times regular old 6. This isn't so pretty, so that's where the I comes in. So instead of writing square root of negative 1 every time, we just replace that with that letter, that constant I. So this becomes I times 6, which we typically write 6I, and that would be your answer. Over here, same idea. To make things a little bit quicker and easier, I'm just going to take that I out. I'm going to rewrite this as square root of negative 1 times square root of 12, and then change it to an I. Do that all in one step. So the way I remember this is I'm just going to go ahead and take an I out. Ow! Sorry, that's more of a visual joke, but I'm taking my eye out. Get it? Poking my eye out. Okay, not that funny. Anyway, so that becomes I times the square root of 12. And now I can simplify square root of 12. That's 2 rad 3. So this becomes 2I times the square root of 3. And that's simplified. Again, an imaginary number, not real. Okay. Now, what if we have I to a power? Some different situations. Well, these come up a lot, so we're going to address them right now. Well, I squared, if you think about I is the square root of negative 1. So I squared is that squared. Well, squares and square roots undo each other, so you actually get negative 1. That's kind of weird. That's never happened before except here, right? In the real numbers, when you square something, you can't get a negative. But this isn't real, it's imaginary. So I squared is actually negative 1. I cubed, well, I cubed you could think of as I times I squared. So that's I times this, which is negative 1, so that's actually negative I. And then I to the 4th, you could think of I to the 4th as I squared times I squared. Well, what's I squared? It's negative 1, so that's negative 1 times negative 1, which is positive 1. What? So fake number to the 4th power is 1. That's really crazy. But it gets even crazier. Because if we keep going, if I go to I to the 5th, watch what happens. I can write that as I to the 4th times I. Well, what's I to the 4th? It's just 1. So it just becomes 1 times I, which is just I. So I to the 5th is the same as just I. That's really weird, but it gets even cooler. So let's keep going. I to the 6th, using our exponent rules again. Whoops. I to the 6th could be written as I to the 4th times I squared. Well, I to the 4th is just 1, so this just becomes 1 times I squared, which is just negative 1. Keep going. I to the 7th could be I to the 4th times I to the 3rd. If we're using those exponent rules again, well, that's 1 times I to the 3rd, which is negative I. I to the 8th is just I to the 4th times I to the 4th, which is 1 times 1, which is 1. And what you notice is we've got a pattern developing here. And it repeats every 4 times. So we had I, then -1, then -I, then 1. I, -1, -I, 1. And you can keep going if you want, but that pattern's going to keep repeating itself. So every multiple of 4, if it's I to a power, that's a multiple of 4, 4, 8, 12, 16, 20, 200, 1,000, anything that's a multiple of 4, it's just going to equal 1. That's kind of crazy. Let's look at a couple examples. So I to the 33rd power. Well, the easiest thing to do is look for, excuse me, look for the closest multiple of 4 to that exponent. So the closest multiple to 4 that I know is 32. So I'm going to rewrite this as I to the 32nd times I to the 1st would get me to the 33rd. And this is just 1, because again, that exponent's a multiple of 4. So that becomes 1 times I to the 1st, which is just I. So I to the 33rd is just I. I to the 47th, let's do the same strategy. So the closest multiple of 4 less than that is the 44th. So I'm going to rewrite this as I to the 44th times I to the 3rd. I to the 44th, again, that's a multiple of 4, so that's just 1 times I to the 3rd. And I to the 3rd is -I. So I to the 47th is just -I. Okay, kind of cool. Now here's where things get wackadoodle. So I want you to try to simplify this problem, and then I'm going to show you how to do it properly. So go ahead and pause and try that yourself. Okay, so now the proper way to do this is to use the strategy that I've already mentioned, where you take the i's out and then simplify. So let's do it that way first. So we get 2I times, I'm going to take the I out, so that's another I times rad 4 times the 5 times, now I'm simplifying the rad -3, again take the I out, I times rad 3. Now I'm going to simplify where I can. I see 2, rad 4 is 2, so this is 2 times 5, which is 20. I see I times I, which is I cubed. And then just that rad 3 left. Well, what's I cubed? I cubed, if you remember from earlier, is -I. So 20 times -I is -20I. And then rad 3. And that would be your answer. Now I'm going to show you the improper way to do it that some of you may have done. And with good reason, but that's why I'm showing you this example, so you don't make this mistake. So what you might have done is said, hey, I can multiply those two radicals together and multiply the stuff on the outside together. So 2I times 5 on the outside. 2I times 5, well, that's just 10I. And then rad -4 times rad -3, if you're using your rules for multiplying radicals, which you remember from before, you could multiply those together and you'd get rad 12. Well, that seems reasonable. And then you can just simplify the rad 12 and you'd get 2 rad 3. So you'd have 10I times 2 rad 3. And then simplify a little more and you'd get 20I rad 3 and say, cool, I'm done. Uh-oh, we got a different answer. Can't get the two different answers to the same problem. One of them has to be wrong. And the one that's wrong is this one. And the reason it's wrong is because this rule for multiplying radicals together only applies to multiplying real numbers. These aren't real numbers, so that rule actually does not work. There are variations. There are some of those rules that do work in imaginary and complex numbers, but here they don't actually work. Kind of crazy. So you have to take the i's out first and then simplify. Okay. Now I mentioned complex numbers a few times. Basically, so we've got the real numbers and we've got the fake numbers. If we put them all together, the reals and the fakes, then we have what we call the complex numbers. So every complex number can be written, in this form. It has a real part and a fake part. You can't combine them together at all, typically. Well, not at all if there's an imaginary part. And so you have to write them separately. And let me show you what that looks like. Here's an example. So if I were to simplify this, that rad negative 25, I'd take the I out. So that's I times rad 25, which is just 5I plus 8. You can't add those together. It's kind of like if this was an x. And then for whatever reason, we always write the real part first and then the fake part. So that is the form that your final answer would be in. That's the standard form for complex numbers. Okay. Now, adding and subtracting complex numbers. When you add and subtract them, they behave essentially the same way as algebraic expressions. The terms with i's in them can be added together. 7i's plus 6i's gives you 13i's. That'd be kind of crazy if you had 13i's. The jokes just keep coming. Okay, but I skipped over the real part, the 5 and the negative 2. 5 plus negative 2 would be 3. So your answer would be 3 plus 13i. Okay? Over here, you just have to remember to distribute the negative when you subtract. So 3 minus 4 is a negative 1. 6i minus negative 8i, that's 6i plus 8i, which is a positive 14i. And notice that our answers, again, look like that a plus bi form. Okay. One more thing to watch out for. If we're multiplying, they start to get a little bit interesting. Here we've got multiplication. Again, it behaves the same way. So if you imagine if those were x's, you'd do 3x times 8x and you'd get 24x squared. So here I squared. But because I squared can be simplified, as we saw earlier, you can go further. I squared is negative 1, so that actually becomes negative 24. So you can go a little bit further with these. Again, treat it with these operations. Treat it like if they were x's, but then look to see if you can simplify. Basically, you're never going to leave an I to a power other than 1 in an answer, ever. And let's see what that looks like in this example. So here, we're going to FOIL. So 2 times negative 3 is negative 6, plus 10i, minus 9i, plus 15i squared. I can combine those two together, so we have negative 6 plus 1i, or just I, plus, whoops, dropped my pen there, plus 15i squared. Wait a minute, I squared is negative 1, so that's 15 times negative 1. That's a negative 15. And now we can go even further. Negative 6 plus negative 15 is negative 21 plus that I. So we can simplify more than if those had actually just been x's. That's all for now. Good luck.